This is Module 10, Section 5.1. In this section, we're going to look at 0 and 1 as exponents, multiplication with exponents, and division with exponents. Exponential expressions. We are going to start with introducing some terminology for exponential expressions. For example, if you're looking at the exponential expression x raised to the third power, the exponent or power is the superscript value of the expression. An exponent tells you how many times to multiply a factor by itself. In other words, it's repeated multiplication. Note that the exponent only applies to what is directly to the left of it. This is important. The exponent is 3 in the above example. Base is defined as the repeated factor, or the portion of the expression to which the exponent applies. The base is x in the above example. For example, x cubed tells you to multiply x together 3 times. So in expanded form, x cubed equals x times x times x. 2 to the fourth tells you to multiply your base of 2 together 4 times, which gives you 2 times 2 times 2 times 2. And if you multiply that left to right, you do get 16. Negative 4 to the fourth. Notice that the base here is put in parentheses, and the rule is the exponent always goes for what's directly to the left of it, so it does include everything in the exponent, or in the parentheses. So negative 4, quantity to the fourth, is negative 4 times negative 4 times negative 4 times negative 4. 4 times 4 times 4 times 4 is 256, and an even number of negative signs is positive. In comparison, let's look at negative 4 to the fourth power without parentheses. Again, the rule is exponents only apply for what's directly to the left of them. So in this case, the thing that's to the left of the 4, exponent of 4, is the number 4, not the negative. So what the exponent of 4 applies to is the 4 only. So we've got 4 times 4 times 4 times 4, which is a positive 256. Then as our last step, we're going to apply that negative, and we get negative 256 for our final answer. Notice the subtle difference between the last two examples. In quantity negative 4 to the fourth, the exponent applies to the entire group, which contains both the 4 and the negative sign. In negative 4 raised to the fourth power, the exponent only applies to the 4, not the negative, because you don't have parentheses. Remember that the exponent only applies to what is directly to the left of it, whether that be a number or whether that be a group. Note that any base raised to the power of 1 is simply the base itself. For example, y to the first power simply equals y. 5 to the first power is simply 5. Also, as can be seen with the above examples as well, any base that does not have an exponent shown can be assumed to have an exponent of 1. And so working backwards, if you had an expression that just had a y written, you'd have to recognize that the understood exponent was 1. And again, y equals y to the first. 5 equals 5 to the first if you really need an exponent in order to do whatever the problem is asking you to do. All right, so let's simplify some examples. For the expressions below, state the bases, the exponents, and expand and evaluate each, if possible. All right, 5 squared. Our base is 5. Our exponent is 2. In expanded form, 5 squared is equal to 5 times 5. And in this case, we can go further and simplify that. 5 times 5 is positive 25. X to the 6. Our base is x. Our exponent is 6. X to the 6th can be written in expanded form as a series of 6 x's being multiplied together. And in that case, because we don't know what x is, there's nothing more we can do unless somebody tells us what our x is representing. Negative 3 squared. All right, remember that rule that the exponent only goes for what's directly to the left of it. So in this case, our base is a positive 3. It is not negative 3. If it was negative 3, you'd have to have parentheses around the negative and the 3. Our exponent is 2. And so negative 3 quantity squared is negative of 3 times 3. The exponent only applies to the 3. So do that first, because exponents come before the negative 1 in this case. So you've got negative 3 times 3 is 9, and that's your final simplified answer is negative 9. Negative 6 squared. In this case, our base is both the positive 6 with the negative because of the parentheses. The exponent goes for what's directly to the left of it. Our exponent is 2. And so if we have negative 6 quantity squared, that is negative 6 times negative 6. 6 times 6 is 36. 2 negatives or double negative equals a positive. 36 as our answer. Okay, in this example, 3 times 4 cubed, our base, or the thing that our exponent applies to, is the 4. Our exponent is 3. So 3 times 4 cubed, orders of operation say we do the exponent first. So we've got 3 times 4 times 4 times 4, which is equal to 3 times, if you take 4 times 4 times 4, you get 64. And 3 times 64 is 192. All right, 1/2 times a squared. Again, the exponent only goes for what's directly to the left of it. Recognize that could be written as 1/2 times a squared if that makes more sense to you. Okay? Again, the exponent only goes for that base. So in this case, our base is a, our exponent is 2. And so in expanded form, we get 1/2 times a times a. And because we don't know what a is, that's about all we can do with that problem. In comparison, let's look at the quantity 1/2 a squared. In this case, the 2 goes for the entire group. So we've got, for our base is that entire quantity, 1/2 a. Our exponent is again 2. In expanded form, we've got 1/2 a times 1/2 a. That's all straight multiplication because it's multiplication in between the 1/2 and the a as well. So if you want to use your commutative property of multiplication, you can. You'd have 1/2 times 1/2 times a, or you can just do that work in your head. 1/2 times 1/2 is 1/4, and then not knowing what the a is, you just have to leave that in expanded form. All right, so let's look at properties of exponents. There are several properties of exponents we're going to look at to make our life easier when we're trying to simplify expressions with several exponents in them. So our first property, which is also referred to as the product rule, says if you have a base raised to an exponent or raised to a power, and you are multiplying that by an identical base raised to another power, you can combine that into a single expression by not multiplying, but rather adding the exponents. So a to the m times a to the n is equal to a to the m plus n. The important thing to know is you've got to have the same base in order to use this property. So our first example here, x to the 5th times x to the 7th, we have the same base and its multiplication, so we can write that as a single base by adding the exponents together, and our simplified expression then would be x to the 5 plus 7 power, or 5 plus 7 is 12, x to the 12th. 2 squared times 2 cubed. Again, that's the same base. In this case, our base is a constant rather than a variable, but the rule works the same. You've got base 2. We're going to add the exponents to combine them. 2 plus 3, of course, is 5. So now we've got 2 to the 5th. Since we have numbers instead of variables, we can go further and get a simplified answer. We've got a series of 5 2's being multiplied together, and multiplying left to right. 2 times 2 is 4. 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 equals 32. All right, our second property of exponent, also called the power rule, says if you have an exponential expression, a raised to the r power, and then that expression is raised to a second power. So you have a power to a power. That also will simplify now not by adding the exponents, but by multiplying the exponents. So for example, if you had the quantity a squared and that was raised to a second power of 5, that can be rewritten without the parentheses by multiplying the exponents. And a to the 2 times 5 power is a to the 10th. Likewise, in the second example, we've got 2 cubed raised to the second power. That's a power to a power, so same base, multiply the exponents. 3 times 2 is 6. Now you've got 2 to the 6th. Now, because that's a numeral, you can expand that further. You've got a series of 6 2's being multiplied. And if you multiply left to right, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And if you multiply that by another 2, you have a simplified answer of 64. All right. Property 3, power of a product rule, says if you have in a group multiplication, so you have multiplication in your group, and that group is raised to a power, then you can take that power and split that out to each factor in the product, and you get an equivalent answer. Now, a lot of times people talk about that as distributing your power. Technically, that's not really correct. This isn't distributive property, but it's the same type of thought process, and so I'll probably refer to it as that as well. The key, though, is you have to have multiplication in your group. So if you look at our first example, you would agree with me that there is understood multiplication between those 3 factors, a, b, and c. That whole group is raised to the 3rd power, so we can take that power and split it out to each of those factors individually and get an equivalent expression, and the multiplication stays between each of those bases. Same thing is true if you have multiplication of constants instead of variables. You can and should split out that power. So now we've got 2 cubed times 3 cubed, and since we have numbers there, we can expand that further. Orders of operations say you do the exponents first, so we need to do the 2 times 2 times 2 group, and we're going to multiply that to the 3 times 3 times 3 group. That gives us 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 3 is 9, times another 3 is 27. And your final step for a complete simplification, 8 times 27 is 216. Now in this case, you could check your answer with that, because if you actually have numbers, you could have taken the problem here and just used orders of operation. So let's do this problem not with properties of exponents, but just with orders of operation. Make sure we get the same answer. If you were doing this problem with orders of operation, you would do inside the parentheses first. Please excuse my dear Aunt Sally. You always do parentheses first. That would give you 2 times 3 is 6. And then 6 cubed would be 6 times 6 times 6. 6 times 6 is 36 times another 6 is 216. Same answer, slightly different method. And in this case, it seems like orders of operation is easier. So you might ask yourself, well, why would I do it this way if it's easier just to use orders of operation, which I knew before? And the answer is sometimes orders of operation is easier, but in an example like this, orders of operation doesn't do anything for you because you don't have numbers, you have variables. So it's important to understand all of the properties of exponents for both variables and constants, even though with constants, sometimes what you knew before is easier. Property 4, this is the power of a quotient rule. It says now, very similar to the property above it, you've got a group, but now in the group, instead of multiplication, you have division. So this says, if you have division in a group, and then you have a power outside of that group, you can split the power out or distribute the power, just like with the multiplication example, and get an equivalent expression. Now, the only thing you have to watch out for, as always, with division problems, is you cannot divide by 0, and you already know that. So, for example, let's say that you were doing this problem. Let's say you had 3 divided by x raised to the 3rd power. You agree with me there's division in your group, then that group has an exponent applied to it. Power of a quotient rule says, like multiplication, you can split that power out. So now you have 3 cubed divided by x cubed. Now there's a little bit you can do there. 3 cubed is 3 times 3 times 3. X cubed, you could write that out as x times x times x, but that's not going to do a whole lot for you. So we'll just leave it as x cubed for this example. Here, the constants, though, you do want to simplify. 3 times 3 is 9, and 9 times 3 is another 27 over x cubed. Let's look at this problem, because this one we can check also with orders of operation to make sure we get the same answer. Let's say I gave you this example and I said, simplify using properties of exponents, which means because it's division, you're going to split that power out to each of those factors individually. That would give you 10 squared divided by 5 squared. 10 squared is 10 times 10. 5 squared, of course, is 5 times 5. If you do that math, 10 times 10 is 100, 5 times 5 is 25, and 100 divided by 25 gives you a simplified answer of 4. Let's look at that problem again, simply using orders of operation. If you have 10 divided by 5 squared, and you decided using orders of operation, you were going to simplify in the parentheses first. Parentheses or groups are always the first thing that you do. 10 divided by 5 is 2. And now if you do the exponent, 2 squared is 2 times 2, which indeed is 4. Same answer as we got over there. Less steps in this case, so for this example, like the one above it, it does seem like orders of operation, if you're dealing strictly with numbers, is easier. Sometimes that's true, but not always. All right, now your 5th rule that you need to memorize is called the quotient rule. It also deals with division, but in a slightly different manner. Okay? This division rule says if you have a base raised to an exponent, and you're dividing that by the same base, that's important, it has to be the same base, raised to a second exponent, you can write that as a single expression by not dividing the exponents, but rather subtracting. Now that's very similar to property number 1, where we were multiplying and we added the exponents. Now we're dividing like bases and we subtract the exponents. Again, when you're dealing with fractions, you know you can't have 0 in your denominator, so watch out for that. Let's say, for example, then, you were asked to simplify x to the 9th divided by x to the 6th. Notice that the base is the same, and it's a division problem, so that falls in this category. We can rewrite that same base and subtract the numerator exponent by the denominator exponent. Order is important. Okay? Subtraction is not commutative, so you must take numerator minus denominator when you're subtracting exponents. All right, 9 minus 6, of course, is x cubed, and there's really not much more we can do with that since we don't know what x is. That's your simplified answer. Let's look at another example with excuse me, bases that are numbers. We've got 2 raised to the 20th power divided by base 2 raised to the 15th power. You would agree with me that that's a division problem. There's a like base there. So using the quotient rule, we can rewrite that same base and subtract the exponents, top minus bottom, which gives us 2 to the 5th. 20 minus 15 is 5. 2 to the 5th can be further simplified, so you would want to. 2 to the 5th is a series of 5 2's being multiplied together. And 2 times 2 times 2 times 2 times 2 ends up giving you a final simplified answer of 32. All right, sixth property, and the final property we're going to look at in this section, says any base raised to the 0 exponent is 1, as long as a is not 0. Just for your own information, 0 raised to the 0 exponent is undefined. But anything else other than 0 raised to the 0 power is 1. So, for example, if you are working a problem and you get an expression that says 5 to the 0, that answer will simplify to 1. X to the 0 also will simplify to 1. You might have an entire group. We'll say 2xyz divided by 3a. If that whole group is raised to the 0 power, it does not matter what's in the group. It simplifies to give you 1. All right, so let's put all of that together, all 6 of those properties, and use properties of exponents to simplify the following examples. Okay, we're going to do a series of several examples. Let's start with this example. Let's say you were asked to simplify y to the 5th times y squared. All right, we've got like bases, and those bases are being multiplied. Property number 1 says that if you're multiplying like bases, you can take that base and write it once, and then add your exponents to get a simplified expression. So y to the 5 plus 2 power is y to the 7th. Let's look at this example. Let's say you have 4 cubed raised to the 3rd power. Now there you have a power expression raised to a 2nd power. Powers to powers multiply, so that gives us 4 to the 3 times 3 power, which is 4 to the 9th. That's a series of 9 4s multiplied together, and that to me certainly is a calculator problem. If you put that in your calculator, you should get 262,192. 144. All right, let's simplify this example. We've got the quantity 4 times t cubed times t to the 6 times t squared, and that whole quantity is raised to the second power. Now, there's a couple of different ways you can do this problem because there are a couple of properties that apply directly. One is you could notice that in the parentheses, and this is more of an orders of operation thought process, can you simplify anything in the parenthesis first? And the answer is yes. You have multiplication of like bases there. So you could use property number 1 to work in the group first and to write that as a single base t and add all of those exponents. So you'd get 3 plus 6 plus 2. And then, of course, that power outside the parentheses is still there because I haven't used that yet. Add the exponents. 3 plus 6 is 9, plus another 2 is 11. So now you've got, in your parentheses, 4t to the 11th, and that quantity is squared. Now you could use, since you have multiplication inside your group, you could take that exponent outside, and because it's multiplication or division, you can split that out. And that will give you 4 squared times, now what do you do if there's already a power there? We've got t to the 11th, and we're applying a power of 2 on top of it. That's exactly what you're going to do. You're going to take that t to the 11th, leave what's already there, and apply the new power right on top of it. Now this is the property that we used right above it, powers to powers multiply. So now you've got 4 squared times t to the 11 times 2 power, powers to powers multiply. And clean that up, 4 squared, 4 times 4 is 16, and 11 times 2 is 22. We've got a final answer of 16t to the 22nd. Now, an alternative way to do that same problem, okay, so this is another way you could approach the problem, is you could take the original problem, you could take that power and distribute it to each term because it's multiplication as your first step if you wanted to. Okay? Now, is that easier? It's really up to you. Let's take a look at it. If you're going to distribute the power first, you'd get 4 to the second power times t cubed to the second power times t to the 6th to the second power times t squared to the second power. We just broke that power, outside power of 2 to each of those factors individually. Now, clean that up. The power to power terms here will multiply. Powers to powers multiply. And here, we can just expand this out. 4 squared is 4 times 4, so that's 16. So powers to powers, we've got t to the 3 times 2 power, t to the 6 times 2 power, t to the 2 times 2 power, which gives us 16 t to the 6th, t to the 12th, t to the 4th. Now at this point, we'd have to combine all those t's. Since we're multiplying like bases, you can combine that into a single base by adding the exponents, which gives us 16 t to the 6 plus 12 plus 4. 6 plus 12 is 18 plus another 4 is 16t to the 22nd. Same answer, slightly different method. Doesn't matter which way you go, though, you're going to get the same answer. All right, let's do one more example on this page. Let's look at 2t divided by 3, that whole quantity raised to the 4th power. Now this is actually a combination of two properties of exponents. Notice you have two things in your group. You have multiplication and you have division. With both multiplication and division, if you have a power outside that group, you can distribute that power to each of those terms individually. That's actually two separate properties that I'm combining into one step. So that would give you 2 to the 4th t to the 4th over 3 to the 4th. Clean that up. 2 to the 4th. 2 times 2 times 2 times 2 would be 2 times 2 is 4, times 2 is 8, times another 2 is 16. T to the 4th, not much you can do with that, so we'll just leave it. 3 to the 4th is 3 times 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, times another 3 is 81. And there's your simplified answer there. All right, let's look at some more examples. Let's look at this problem. Let's say you're asked to take b to the 4th times b to the 5th divided by b squared b cubed. Now again, like with the previous problem, there is more than one way you can approach this problem. I'm going to choose to simplify the numerator and the denominator separately first. So looking in the numerator, note that that's understood multiplication. Those are like bases, so because of property number 1, I can combine that into a single base by adding the exponents. Likewise, in the denominator, I can combine that into a single base by adding the exponents. That now gives me b to the 9th divided by b to the 5th. And those like bases then, with division, will also combine into a single base, but rather than adding, you're going to subtract numerator minus denominator. And 9 minus 5, of course, is 4, so our simplified answer is b to the 4th. All right, let's look at this example. Let's say that you have m cubed n to the 4th, and that entire quantity is cubed. And we're going to divide that by the quantity m times n squared quantity cubed. All right, we've got multiplication in our groups. So since we have an outside power, we can distribute that power. And likewise in the denominator, we can distribute that power to get rid of our parentheses. So that gives us, now there's already a power there, so when you distribute that outside power will distribute right on top of the power that was originally associated with that base. So we've got m cubed cubed times n to the 4th cubed divided by, if we distribute that power in the denominator, m cubed times n squared cubed. All right, powers to powers multiply. So we've got m to the 3 times 3 is 9. N to the 4 times 3 is 12, divided by m cubed times n to the 2 times 3 is 6. Notice we have like bases here. So with like bases, if you have division, you can write that as a single base by subtracting the exponents, numerator minus denominator. So we can do that for the m base and the n base, 12 minus 6. And clean that up. You've got m to the 9 minus 3 is 6. N to the 12 minus 6 also is 6. You cannot combine the m and the n because those are different bases, and so that is your final answer, m to the 6 times n to the 6. All right, one final example. Let's say you have the quantity negative 6 y to the 4th y to the 5th divided by 5y cubed y to the fifth, and that whole quantity is raised to the second power. Now there's several ways you can do this. If you wanted to just look in the group and combine all of those like bases before you ever looked at the power on the outside, you could do that. Okay? Another option is if you really wanted to get rid of that grouping symbol, you could, as your first step, distribute that power of 2 to each and every term or factor in that parenthesis. As long as everything is multiplication and division, that's okay. And it is. So that would give us, now be careful on that first term. If you write negative 6 squared, that's wrong. Because written like this, from earlier in this section, we said that that power of 2 would only apply to the 6, not the negative 6. So you do need to put parentheses around the negative 6 to indicate that the power of 2 that you distributed does go for the entire term there, both the 6 and the negative. All right, so then you've also got y to the fourth squared times y to the fifth squared divided by 5 squared, y cubed squared, and y to the fifth squared. All right, now clean that up. Negative 6 squared. Negative 6 times negative 6 is positive 36. Here, powers to powers multiply. So we've got y to the 4 times 2 is 8. Here, y to the 5 times 2 is y to the 10th. Divided by 5 squared, 5 times 5 is 25. Y cubed to the second power, 3 times 2 is y to the 6th. And here, 5 times 2 is y to the 10th. All right, now, like a previous example, I'm going to choose to combine my like bases in my numerator and then my denominator. So, like bases being multiplied to combine that into a single expression, you're now going to add your exponents. And same thing is true down here. You're going to have to add that 6 plus 10. That now gives us 36y to the 18th divided by 25y to the 16th. Now we have like bases being divided, so we can subtract those exponents, and we've got 36. Now when you subtract exponents, that always gives you a number where the value that you're left with is up in the numerator. So what you're going to get when you subtract is going to be up in the numerator. 18 minus 16, okay, we'll do it here, y to the 18 minus 16 does leave you with y squared, and again, that's up in the numerator always when you subtract. The only thing left in the denominator then is that 25. Now ask yourself, is there a common factor that I could factor out of 36 and 25? And I believe the answer to that is no. So your final answer will be 36y squared divided by 25. This is the end of Module 10, Section 5.1 material. You now should complete the homework for Section 5.1 found in my math lab. And when you have successfully completed the homework, proceed to the video for Module 10, Section 5.2.